We have seek for sequentially combining behaviors. So as you might expect, we have sim or simultaneous for simultaneous combinations of behaviors. Sim is exactly the same as the function sum or the operator plus. Um, the semantics are that sim evaluates a list of behaviors and forms their sum, which is equivalent to audio mixing. And here's an example that plays C4 sine tone and a G4 sine tone at the same time. The next example shows a little bit of variation and allows us to talk about the semantics a little bit more closely. Here we have sim of a bunch of expressions, but notice that some of these expressions are shifted by 0.1, 0.2, 0.3. So what happens in this case? Well, either these shifts are going to apply or somehow sim is going to make everything simultaneous. Well, in fact, the semantics are that sim evaluates all of these behaviors at the same start time, but of course, some of these behaviors have shift factors, so they further modify the environment with additional shifts of 0.1, 0.2, 0.3, and so on. And so the sounds that are computed by these oscillators are shifted in time. And when the results come back as these immutable sounds, sim respects their respective starting times and adds them up together, but they will not all start at the same time. They'll all be shifted. So sim is actually a very useful operator for mixing and organizing things in time if you use these shift operators. And we're going to listen to this now. So notice also in this sound, we have no envelopes on these tones, so they have very sudden onsets and sudden offsets. The endings actually generate little pops, and those are the 4 pops you hear at the end. I think that actually sounds kind of interesting, but I apologize for leaving these artifacts in this sound.